The phone in your hand feels solid, yet physics reveals a device composed of 99.99% empty space. If you collapsed that space out of every person on Earth, the entire human race would fit inside a single sugar cube. What remains is a collection of energy fields vibrating at specific frequencies. Your brain reconstructs a simplified 3D model from raw electrical signals rather than showing you the world as it is. Outside your skull, color and sound vanish. You navigate a silent landscape of electromagnetic waves and air pressure, which your brain translates into a blue sky or a familiar voice. Cognitive scientist Donald Hoffman argues that evolution prioritized survival efficiency over objective accuracy. Our senses developed to provide useful shortcuts, similar to the icons on a computer desktop. A folder icon allows you to interact with a file without needing to see the millions of lines of binary code or the hardware shifts happening inside the drive. The icon simplifies a reality that is too complex for the user to process directly. If our physical surroundings function as a biological user interface, understanding the universe requires stripping away these survival-based illusions to find the underlying architecture. When physicists examine the fundamental ingredients of reality, the standard rules break down. At the quantum scale, particles that defy our intuition of how objects move. In the double-slit experiment, an unobserved particle travels as a wave, passing through two slits simultaneously to create an interference pattern. The moment a detector measures it, the wave collapses into a single point, behaving as a solid object. Bell's theorem mathematically confirmed that this isn't due to a lack of data or better tools. Particles lack hidden properties or fixed locations until the moment of measurement. They exist as mathematical possibilities until they are observed. This understanding of quantum entanglement and the role of the observer led to the 2022 Nobel Prize in Physics, moving these concepts from theoretical debate into the scientific mainstream. Since physical matter requires observation to take a fixed form, the grid that matter sits on, space and time, becomes the next subject of scrutiny. Space appears continuous, but at the Planck length, distances lose their meaning. The smooth geometry we experience fractures into a disjointed network of quantum connections. Research into black holes by physicists Jacob Bekenstein and Stephen Hawking provided a new way to visualize this breakdown. They struggle to explain what happens to the information of objects swallowed by a gravitational singularity. Bekenstein discovered that a black hole's information capacity is tied to its surface area, not its volume. Every star and planet that falls inside has its data encoded on the two-dimensional event horizon, similar to a record etched onto a surface. The ADS-CFT correspondence, or the holographic principle, suggests this logic applies to the entire universe. Our three-dimensional world may function as a projection generated by data interacting on a lower dimensional boundary. If distance is a projection and time emerges from the complexity of these interactions, the universe functions less like a physical container and more like a massive rendering of data. Stripping away matter, space, and time leaves only the raw data that defines their interactions. Without these physical layers, information remains as the foundational building block. Physicist John Wheeler described this as it from bit. He proposed that every physical object is ultimately the result of binary distinctions, a series of yes or no, one or zero choices that manifest as matter. Research by Stephen Wolfram suggests the universe emerges from simple, recursive rules, a sequence of logic gates processing information in real time to generate the complexity we see. If reality consists of informational code updating itself, there must be a trigger that causes this data to render into the physical world we experience. The measurement problem remains the central mystery of this process. Physicists continue to debate exactly what causes a probability wave to snap into a fixed reality. Standard measuring devices are themselves composed of quantum atoms. In theory, a camera or sensor should also exist in a state of probability until it too is observed, creating an endless chain of uncertainty. The Wigner's friend thought experiment suggests this loop only reaches a definitive conclusion when it meets a conscious mind. In this interpretation, the lab and everything in it remain in a state of flux until the results are perceived. John Wheeler's participatory universe theory proposes that without an observer to perceive it, the universe lacks a meaningful way to exist. It remains a cloud of unrendered data until awareness brings it into focus. In the participatory universe model, consciousness acts as the catalyst, collapsing infinite possibilities into the singular reality we experience. Your physical identity is part of this fluid system. The atoms in your body are constantly replaced, and your thoughts are transient electrical patterns moving through a biological interface. Even as matter, space, and time dissolve under scrutiny, the subjective experience of awareness remains. You are currently perceiving this information, and that act of perception persists regardless of the physical substrate behind it. The act of observation links your awareness to the quantum void. By looking and measuring, you physically manifest the universe, one moment at a time. Your awareness provides the feedback loop necessary for the informational code of reality to render into form. Reality remains a recursive, unresolved act of becoming, an ongoing conversation between the observer and the observed.